This is Learning Assessment Problem 616. This problem deals with an operational amplifier differentiator circuit to which the waveform V1 of t is applied, and we are asked to determine the shape of the output waveform. The parameters of the differentiator output expression will be here. The R2 and the C1 are circuit elements in the differentiator circuit. So we'll begin by breaking the input waveform up into segments, and we'll number these 1, 2, 3, and 4. Here we have the time intervals for those segments 1, 2, 3, and 4. And first we'll wish to determine the derivatives or the slopes in each of those segments. Since this is a nice piecewise linear shape, we can just do the rise divided by the run for each segment to obtain that slope. So in the interval from 0 to 1 second, we have the slope is 6 volts divided by 1 second, which is 6 volts per second. In the second interval from 1 to 3 seconds, horizontal line indicates a slope of 0. In the third interval from 3 seconds to 4 seconds, the waveform returns to 0, so our slope there would be a change of minus 6 volts divided by 1 second is minus 6 volts per second. And finally, for time greater than 4 seconds, we'll assume that the waveform is just constant at a 0 value and the slope is 0. Now the output of this differentiator circuit will be minus 2 ohms times 2 farads dV1 dt, which is equal to minus 4 seconds will be the units of the RC product, dV1 dt. So for each of the intervals we can calculate that output voltage. We'll have a minus 4 seconds times 6 volts per second is equal to minus 24 volts. For the second interval, the slope is 0, so the output will be 0. In the third interval, we'll have minus 4 seconds times minus 6 volts per second is equal to plus 24 volts for the output. And for time greater than 4 seconds, the output will continue to be 0. Now we can go to a plot of this information. Time 0 up to time 1 second, the output voltage is constant at minus 24 volts. At 1 second, the output collapses to 0 volts. And at 3 seconds, we have a rise to plus 24 volts, continuing on until time 4 seconds, where the waveform at the output again falls to 0 and continues at 0 level.